In this video, I'm going to do the free response that I gave you as review for Unit 2 test. Okay, so number 1 says that you have a mass of 2 kilograms and you're pulling with a force of 15 newtons. There is a coefficient of friction, a mu k here, of 0.25. Okay, now it says draw and label the forces. So here we're going to draw a free body diagram for the forces acting on the 2 kilogram box. So really the only forces that we have are normal force and force gravitational. And then in this direction we have T because it's the tension in a string. And then in the left-hand direction we have force friction. Okay, so that's all we draw. Now it says calculate the magnitude of the acceleration. So we're working on forces in this direction. Okay, in the horizontal direction, so we're going to say that Ft minus Fk is equal to ma. Okay, and the tension in the string is 15 newtons. Friction is mu k Fn. Actually, let me just rewrite this until we can plug in. Right, so we've got Ft minus mu k Fn is equal to ma. And Fn is equivalent to Fg, so Ft minus mu k Fg is equal to ma. And then Fg is mg, so Ft minus mu k mg equals ma. So I'm just going to plug in up here, 15 newtons minus 0.25 times 2 times 10 equals 2a. So let me find a calculator here. Let's see. 2 times 10 times 0.25 is 5. Okay, so 10 equals 2a, so a is equal to 5 meters per second squared. Okay. Alright, then on to the back. Now in this scenario, it says that you have a the same block, but now instead of pulling with just some arbitrary force of 15 newtons, the force is actually caused by the by a weight here. Okay, so if I'm going to do part C, C asked me to calculate the acceleration. Now it's going to be a little bit different from the problem on the front, because in this case now instead of just having a mass of 2 kilograms, we're going to have a mass of the entire system that is 4 kilograms. So I actually get that the force due to tension minus the mu k mg of this guy is equal to m of a plus m of b times acceleration. Okay, so it's going to change it just a little bit. So 15 minus 0.25 times 10 times 20 is equal to now 4a. So again, we get 10 equals 4a, and 10 divided by 4 is 2.5. Oh, of course, 2.5 meters per second squared. All right, now it says calculate the tension in the string between the two boxes. Okay, now let me just kind of explain this. The tension in the string is a result of both this thing pulling in this direction, so 15 newtons. So there's tension in this direction of 15 newtons. Okay. However, there is a force due to friction back in this direction acting on this, which is equivalent to 10 newtons. Okay. Now, really, when we talk about tension in a string, most often tension is just going to be equal to this weight, and we don't really have to worry about how tense the string really is. Okay, but in this case, it's actually asking for tension, and we have 2 forces that are contributing to it. And so the tension in the string connecting these 2 blocks would actually be equivalent to these two forces together. So if we pull on the string in opposite directions, so in this direction and that direction, there's going to be 15 newtons to the right and 10 newtons to the left. So it's actually 25 newtons of tension in the string. This question really isn't asked that often, which is why I don't go too much into tension. It also can get a little confusing to people because of the this idea of using tension being the weight of this. So it's not too important to me, part D, but hopefully you understand that now, and maybe you can come back and look at it later. All right. Now, E says calculate the distance the 1.5 kilogram box will descend in 4 seconds. Okay? So, or in 0.4 seconds. So I have acceleration here. Okay? The whole system is moving. So I want to know D. Okay? We'll assume that the initial velocity of it is 0. And I'm given a time of 0.4 seconds. So we're just going to use the constant acceleration equation where d is equal to v initial t, but that term will cancel. So it's actually equal to 1/2 at squared. So 1/2 of 2.5 times 0.4 squared. So 0.4 squared times 1.25 gives me 0.2 meters. All right? Now, part F, so that's part C, this is part D, this is E. Part F says, if the system is set up in a laboratory and the acceleration of the 1.5 kilogram box is experimentally determined, the experimental value is found to be smaller than the value calculated above. If the given value for the coefficient of friction is correct and air resistance is negligible, explain briefly but specifically why the experimental value of the acceleration is smaller. Okay, so there's a couple of different reasons that we could state here. Okay, one of the reasons is the weight of the string. Okay, so in the problem we ignored the weight of the string, so that will affect the acceleration because now the system actually has more weight than just 4 kilograms. The other thing that we could state would be the friction in the pulley. Okay, so as the string passes over the pulley, there's going to be friction that slows it down. So really, these are two different reasons why our acceleration experimentally would be less than what we calculated here.